Okay, thanks for joining. Especially, we were not expecting such a large crowd for this session at the beginning when we submitted that session, so thanks a lot. Let's start with a quick introduction. I'm Dimitri Desmet, and with Romain Decker, we'll spend the next hour. Oh, let's switch to the right slides. Can you do that? We'll spend the next hour to talk about advanced network services. We're both working in or for the NSX business unit. We've been there for quite a while, so we'll cover this. But at the end, if you have some other questions, we can also address those if you want. So that's not the only thing we have in common working for NSX. As you can now guess with this accent, I'm not an English native speaker, but I speak also with hands. So if you don't understand my English, you should follow me with the signs, and should be fine, hopefully. So we won't talk about baguette and beret and all that stuff, but advanced network services. So let's jump into it. Oh yeah, one word before that. I joined NSX through the acquisition of Nicira. You may have heard about it. It was 4 years ago, so I've been in the network virtualization for 5 years now. And we see really the hockey stick that vCenter had like 15 years ago. It sounds like ages. But the adoption of NSX is tremendous now. And that's pretty cool. And I wanted to know who knows what is NSX in the audience? Yeah, 99%. But that's cool. When I started 4 years ago in my first VMworld, that was not the case at all. Who played with NSX? Yeah, 80 and 85%. Who is using NSX in production? Part of those numbers. Wow. 30%, 40%? No, pretty amazing. Okay, so another proof that's getting there. Pretty cool. So thanks for that. And you pretty much all know, because 99% raised their hand on what is NSX. So you know that NSX replies to a large number of use cases. We try to make them in 3 categories, but actually that's more than that. But the big categories are around security, around automation, and around multi-data center with the disaster recovery use case or the active data center. This session is not really taking a vertical per se, but it's talking about the advanced network services. And so it's a little bit on addressing a little bit of all of that. The disclaimer that the second day, you've seen it many times, so let's not spend time on this, especially we don't talk about roadmap here. Everything we'll talk about is available today, so forget about that. Okay, so how do we split the day or the next hour? We'll have a quick introduction for the 1% of you who don't know NSX. I'll do it very quick. Then we'll go to the core of the day. We'll talk about the advanced network services, so firewalling, load balancing, and all the VPN stuff. And we'll do a wrap-up to summarize all the great stuff we will talk about. And then we'll open to a Q&A. We should have 5-10 minutes at the end. It's too large audience to make it interactive. But don't worry, we'll have a Q&A, and at the end, we'll stay longer if needed. So, for the 1% who don't know NSX, what is NSX? The goal of NSX is really to reproduce all the network and security services you have in your data centers. And if you think about it, there are not so many. You have switching, you have L2, you have routing, you have firewalling, you have, with the security stuff, you have the load balancing with all the service that helps you to scale up your applications, to provide high availability of your application, and the VPN services. That's pretty much it. That's only 5 services that exist in network and security. It's not that much. I don't say you don't have a tough job, but it's not so many services you have to learn. And we reproduce all that in logical space. By the way, I'm a network engineer too, so I should include myself in this. And then, because it's in logical space, you can create one big, large network service, or plenty of them. It's the same thing. Now, why did I insist on logical space? It's because it gives you tremendous benefits. It's like compute virtualization 15 years ago with vSphere. Why that has been a big success? It's because making compute in logical space gives you speed. It's much faster to create a VM versus a physical server. Network is the same. To create a router, to create a firewall, to configure it, it's much simpler if it's in logical space. Agility, your network is everywhere. Security, Romain will talk about that, why security is actually better, deeper when it's done in logical space. Performance, it's counterintuitive, but actually making it its software versus, the big box, the appliance, it's actually more performance to make it in software. We'll talk about that in a minute. And it's also easier to manage because think about it, everything, all your services are done in a single place. You have to configure all your, manage, operate, troubleshoot, all your switching, routing, firewalling, load balancing, VPN from the same place. It makes your life easier instead of having 20 SSH connections to your top of the rack, another to a router, another UI to F5 and whatever. So it makes your life easier. You can save, backup, roll back your configuration centrally in one click. It's pretty cool. And you have tools like Traceflow. I won't talk about it. But yeah, it makes actually everything much better to make it in logical space for network like it was the case for compute 10 plus years ago. Okay, that's the end of the introduction. So I told you that's a quick one. Now let's go to the core of that session. That's why you came. Firewalling, load balancing, and VPN advanced services. And Romain will start with firewalling.
Thank you, Dimitri. I will now start with firewall. First, I will present what are the various security services offered in NSX. And I will translate them into benefits before spending a few minutes on the performance. I will also develop the latest improvements for NSX in terms of security. And I will conclude on the integration with third party. So really here, what should I ask? What do we offer in terms of security? We offer, of course, a stateful layer 4 firewall, but also virtualization-aware security, meaning that the security follows the VM, regardless from where it's running. And we also have intra-subnet communication, meaning that we can block or allow traffic in the same layer 2. But what makes NSX so special and so unique is that it's not a product. It's not a network and security product. It's a platform. And because of that, we can integrate with many third parties to offer additional services, such as layer 7 firewall or malware protection. And what makes NSX so powerful? It's where it's located. In traditional security, you have firewalls and enforcing points living at the edges of your networks. And with that approach, if you buy a firewall, if you buy an appliance, you are limited to its scale. NSX approach is different. NSX approach is to have a firewall in a distributed fashion. So you're still sitting at your computer, doing your configuration, your rules, configuring the security. But when you hit the button, the rules are pushed down to all of your hypervisors in the kernel. So the rules you just configured, they are living in the kernel of all your hypervisors. And that's a great power for scale and for performance. And because you have firewalls in the kernel, you have firewalls everywhere. And something else great with NSX, it sits in the kernel. Because of that, we can enforce rules and security at the VNIC level, at the virtual NIC, on every virtual NIC from every VM. And this allows more control on each individual VM. And you can block or allow traffic before it hits the network. And you can do that in the same layer 2. So even if you have two servers running on the same ESXi on the same layer 2, you can block the traffic between the two servers. And the distributed firewalls doesn't require any changes on your network. It does not require VXLAN. You can do distributed firewall security on regular distributed port group with backed by VLANs and on logical switches backed by VXLANs. So if I want to recap, we have great performances, amazing scale out, but we also have microsegmentation, which is a segmentation beyond the usual VLANs and subnet boundaries. And you might wonder, is it difficult to switch to NSX? Well, I used to configure checkpoint firewalls in the past, and I was creating rules with the usual 5 tuples. And you create source destinations based on IP objects, networks. You define the ports and the protocols. You classify maybe your rules into sections. And you can do exactly the same with NSX. You can use MAC addresses, IP addresses, ranges, subnets, and you can define your rules, source destinations, and classify them into sections. So the learning curve is really easy for existing security administrator. You can configure your distributed firewall exactly the same way. But what you can also do for simplicity is to use NSX and vCenter objects. You can use, for example, VM names as a source of a rule, but even if you don't know its IP, which is more simpler. But this is only an example. You can also create rules based on objects like data centers, clusters, distributed port group, logical switches, and so on. So this is really a simple way of configuring firewall rules. About ports and protocols, the same story applies, but most firewall vendors already do that. We do support some ALGs. Some protocols like FTP require dynamic ports to be opened, and the firewall needs to learn which ports and to understand the application to learn which ports it has to dynamically open. Something else great with NSX, the service composer. This is maybe my favorite feature. We have the traditional way of configuring the firewall, like using IP addresses, or the new way, using NSX objects or vCenter objects. But you can use Service Composer. It provides the ability to dissociate the security from the objects on which you want to apply. So on one hand, you have the security policies, which is really the security you want to define. It's firewall rules. You want to allow SSH to a bunch of servers. You want to prevent Facebook access to your interns, or you want to prevent SQL injection to add malware protection to some VMs. On the other hand, you have security groups. It's an abstraction. It's a container for objects, which can be dynamically or statically included. So you can add dynamically VMs into security group based on criteria membership like VM names or computer OS type, security tags, and so on. So when the security policies is how you want to protect, the security group defines what you want to protect. And finally, at the end, you only have to apply policies to the group. This is really powerful. And you might wonder, how should I create and configure my firewall rules now? I have the possibility to configure them with IP objects, with NSX objects, vCenter objects, to use the Service Composer. Well, it depends of your application. It depends of your background. It depends if it's brownfield or greenfield. If it's greenfield, it's easy because you can adopt a positive security model with you block all traffic and you allow only on purpose. But not everyone has the chance to start with a blank page. You have legacy applications, you have existing applications that need security. You can either copy your existing firewall configuration or ask your application owners for the traffic they need. But what you can also do is adopt a negative security model. You can allow all, log, the default firewall rule, and then you onboard your application and you analyze the traffic flows. You can analyze with all the tools that we have at our disposal, log analysis, port mirroring, IPFix, and so on. And at the end, you can do a mix of Service Composer and firewall rule tables with IP objects and vCenter objects. And if you classify rules into 3 different categories, network-based, infrastructure-based, and application-based, you can use, like, for example, IP objects for everything network-based. You want to access that network that is remote. If you define application infrastructure rules for everything common shared application, like DNS, NTP, Active Directory, and so on, you can use maybe vCenter objects. And finally, for the application-based roles, you can use the service composer. Now, some customers might be afraid that adding more security features on top of ESXi impacts the performance. Well, what you can do is a simple test. It's not the usual home lab, but still you can try. You can take two ESXi hosts each with 10 gig NIC, two 10 gig NICs connected to a 10 gig switch. 4 VMs, VM1 talk to VM3 and VM2 talk to VM4. And you can use a tool that will push packets as fast as it can, like iPerf, and try with and without firewall. So without firewall, distributed firewall enabled, only switching, we can do roughly 20 gig per host. And if you enable distributed firewall, there is a little delta, a little drop, but it's quite negligible, especially because this is per ESXi host. It's per ESXi host, meaning that if you scale out the number of your ESXi hosts, you will scale out your firewall bandwidth. If you want to learn more about performance, you can check out the NSX performance deep dive session. NSX is not, of course, a static product. We are improving it, adding more features. I've combined a few of the latest improvements in a slide. And we introduced lately the TFTP ALG support for the application level gateway. We also support now Windows 10 for everything touching guest introspection, like identity firewall, malware protection, and so on. We also offer now SYN flood protection to protect VMs from north-south DOS and DDoS. So NSX provides a stateful layer 4 firewall and microsegmentation, which is great for many, many customers. But some customers, they want to extend their security by adding some additional features. So NSX might not do everything that your network firewall do natively, but you can enhance it and integrate with third party to offer additional services, like layer 7 firewall with Palo Alto or Checkpoint, or using Trend or Symantec to offer malware protection. And now, let's switch to a little demo. So let's imagine that I just joined the company. My first job is to configure NSX, a new deployment, greenfield deployment, and the application owner has harmonized their application development in the past in 3 different tiers. And to be original, I kept web tier, app tier, and DB tier. So the default firewall rule in NSX is to allow. And because I don't like this, I will set it to block, or maybe more to deny, because it's more powerful for the demo. And then I will configure the security by creating a security group around each tier, around DB tier, app tier, web tier, and then I will configure the firewall rules using the service composer. But this allows only the communication for the application. I still want to manage the servers, and I have an admin laptop in my lab, and I want to allow it to connect into SSH to the servers. And I can prove then the communication inside the same layer 2 isn't possible. And finally, I will scale out my web tier, maybe because of a traffic peak, and I will show that cloning a single web VM and will automatically add it into the correct security group and add the correct security policies without my intervention. So that's my lab. I already deployed some of the stuff and created some objects into NSX for the sake of time. So I have a compute cluster A, and I have my application running. It's 5 VMs, 2 app VM, 1 DB VM, 2 web VMs. Nothing fancy. The application looks like this. So it's a default NSX installation. So the default firewall rule is still set to allow. So it's not very fancy, but I can see the server chain. I'm connecting to Web 01, touching App 01 and DB 01. So if I want to adopt a positive security model, I can go back to NSX and change the default firewall rule to set it to deny. So in my default section, I have allow for the moment. And before doing that, I will connect to my Web01 in SSH. So I can connect to Web01. I can show its IP, so it's 10.10.10.11, and I can ping Web02, sorry, QWERTY, demo effect. Ping Web02, so it's 10.10.10.12. Now I will change the default firewall to reject. Save and publish the changes. As soon as I've done that, I shouldn't be able to connect to the application anymore. So the seed can be reached, and my SSH session should be dropping. Okay, it was fast, but the connection dropped. So now I want to use the service composer. I could do a usual firewall rule in a new section and add the various elements to allow the communication. But I can also use the service composer. So I created 3 security policies. The first one is to allow the communication from any to the web tier in HTTP. So if I look inside the security policies, it really looks like this. The source is any. The destination is the policy's security group. The service is HTTP, and the action is allowed. And I have the same kind of security policies for the communication from the web tier to the app tier, and from the communication from the app tier to the DB tier in MySQL. I also have created security groups, so 3 different security groups. If I look like inside one, I can check what kind of criteria I used to configure it. So I defined a dynamic membership based on the VM name. So every VM containing the web and their name will be automatically added into that group without my intervention. And finally, I only have to apply the security policies to the group. So for the last one, I apply the policy to the DB security group. For the communication between the web tier and the app tier, I apply the policy to the app security group. And finally, for the communication from any to the web tier, I apply the policy to the web security group. Done. And how does it translate into firewall rules? So for each security policy, I have a section that is created with one firewall rule. Of course, if you include many firewall rules in your security policy, you will have many here. And I have the source destination, and the destination now is my security group with 2 web servers that match the dynamic criteria membership. And I should check my application should be available now. Okay. But I still want to connect into SSH. So I could continue and use the service composer to do that. But I can also create a new section here. And create a rule. I already created an object for my, no, not here. Oh. I already created an object for my laptop. So it's, yeah. My lab is killing me. Okay, so the object for my laptop is an IP set. It's only an IP, it's a physical server. So I created its admin laptop, its IP, it's 10.10.0.0.10. And instead of using a security group or VM names, I could say that the destination is everything contained into the compute cluster A. And the service is SSH. And finally, I apply the configuration. So now I should be able to reconnect to my web server. Okay. But because the default firewall is still set to deny, I shouldn't be able to ping my Web02 servers. So the destination is prohibited. And finally, if I'm experiencing maybe in a few weeks a peak in the traffic, I can simply clone a VM, a web VM, to scale out my application. So I've already done the cloning process, and I've renamed the VM into placeholder. But if I rename it into Web03, it will be automatically added into the security group. And because of that, the security policies and the firewall will be automatically added without my intervention. So because the name now is matching the web security group membership, if I check in the firewall, in the first rule, I should have the Web03 VM in the security group. So if I check, I have my Web03 here in the security group, and it's automatically done. So that was the end of the demo.
Pretty cool. Okay, thanks a lot. So how did you find that? Did you learn something on the security or not? Yeah, good. So that's the goal, to show you that there are many ways. It's not to show you that there is a good way or bad way. They're just, you can do the old way, like your dad was doing firewalling, and still use IP addresses and subnet, and fine, you'll still have your pay raise at the end of the year. Or you can use other tools and makes your life easy or easier, and have free time to go to the beach outside and still have your pay raise at the end of the year. So it's just, yeah, it's not a product, it's a platform. It can be enhanced with product, and there are many ways to do things. There is one way we didn't show you because we ran out of time. It's automation. Instead of doing click, 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 you can also automate that with the automation tool you love. If you're a VMware addict, you can automate that with VRO, with PowerCLI. If you're not completely a VMware addict, with Ansible, with Python, there are tools to do automation. Okay? So now let's jump to the next section. Load balancing. So I follow actually the same agenda Romain did. We'll talk about the services, what you have in terms of load balancing services available natively on NSX. How do you translate that to benefits for you? What does that give you? Few words on performance, because that's like firewall, it's something you should not be scared of. So to use our service because of performance reasons. If you haven't followed NSX closely in the latest quarters, I'll speak about the latest enhancements. I'll talk also about the ecosystem, like in the firewalling, where you have an ecosystem with partners enhancing NSX capabilities on the security side. I'll talk about the ecosystem on the load balancing. And in between, I'll do a demo on a cool feature we introduced, distributed load balancing, around the end of this section. A few words, we'll go quite deep. But if you want to go even deeper in load balancing, there is a dedicated load balancing session, NET7907, and I definitely recommend you to attend that one. So, what do we do in terms of load balancing? Who knows load balancing here? even more than 99% of people know NSX, and 100% know load balancing. So let's go fast. We do basic load balancing. So any kind of layer 4 TCP, UDP load balancing. So we can load balance LDAP, LDAP-S, FTP, DNS, obviously HTTP, HTTPS. And as any load balancer, what we do is people go to a VIP, and the load balancer, NSX, will split the load among server pool. And obviously, if the load increases, then the load on the backend pool will increase. Something which is not trivial, but you can do easily. Keep in mind, this is the VMs are running on vCenter, most likely. And vCenter has tools to detect the usage of the VM. So if you use those tools to detect, oh, my VMs, web servers in the pool are getting hot, you can use the vSphere capabilities, nothing to do with NSX, the vSphere capabilities to clone one of those VMs, and automatically NSX will add that, in this example, third VM in the pool and spread the load among now 3 pool members. So that's what we do. Of course, like any load balancer, we also check the application health. So if the VM is dead or the application running on the VM is dead, we'll detect that. And obviously, we remove it automatically, no human intervention out of the pool. And service, the application, the VIP, is still up and running, and your end users are happy and don't detect anything. So we do basic load balancing. We do also advanced load balancing with any kind of layer 7 manipulation. So for web, HTTP, HTTPS. So we can see what's coming on in terms of requests. We can see the response, the web HTTP response, and make actions on that. Block specific pages because they are coming from outside users. Or like in the slideshow, let's say you have limited number of public IPv4 addresses, and you have plenty of applications. So you could use the same VIP, the same public IP address, and the load balancer behind that VIP will look at the host, app1, and because it's app1, then it will select pool number 1 with web1, web2. If it's the same VIP, the destination, but the host is app2, it will go to pool 2, app3, pool 3. I mean, most of you, I hope your load balancer can do that as well. So it's not reinventing the wheel, but we do support that as well, natively. We do also all kind of stuff on SSL. The very popular SSL offload, where people come on HTTPS, the load balancer will terminate HTTPS and load balance traffic on HTTP. That has two benefits. You don't have to run HTTPS on your servers, so your servers can handle more traffic. And you don't have to manage your certificate, SSL certificate, on all your web servers, but on a central point, NSX. So we support this very popular mode. We support also the non-popular modes of pass-through. The traffic will go HTTPS up to the backend servers. We don't terminate on the load balancer NSX HTTPS. Or end-to-end SSL if you're a security freak. You want HTTPS terminated on the load balancer NSX because you want to do the layer 7 inspection manipulation I talked about before, but you still want to talk HTTPS to your backend servers. You don't want clear text anywhere in your data center. So it's not very popular, but banks, insurance, yeah, they like this one a little bit. So we support all that. Now, what does that give you to use load balancing within NSX natively? As I said in the introduction, it makes your life simpler because now you can manage that service, like your switching, your routing, your security, from the same place. You have a central place to configure all your services. And if you love automation, same thing, you automate that one as well from the same tools you have. Also, the learning curve is very simple. As I look, I'm old. So I come from a load balancer background, and learning NSX was pretty simple. I mean, the concepts are the same. How do you do load balancing? I mean, you have a pool of servers. You configure a pool of servers. You configure health check to monitor the server's health. And you configure your VIP, and you're done. So learning and load balancing on NSX is very simple when you have like 100% of you knowledge on load balancing. Also, like Romain explained before, you can do the old way like your dad was doing load balancing and configure IP addresses everywhere, and that's fine, keep doing that on NSX, or you can use NSX or vSphere objects and don't play with IP addresses anymore and make your configuration simpler. And the last point, which is maybe for some of you, I don't know who is buying stuff or just operating stuff, but if you buy stuff, that last point is important for you because it's actually very cost effective because it's included from the license advanced. So whatever, if you use load balancing on NSX with 1 load balancer or 10 load balancers or 100 load balancers on NSX, anyway, it's all included and you don't pay extra for that. So it makes the solution very effective, cost effective. Okay, performance. In the enterprise, I can argue, I mean, we reply to 99.999% of your performance needs. Now, of course, okay, we cannot load balance YouTube. We cannot load balance Facebook. They have terabytes of traffic, and it's too much for me. But I can argue in the enterprise, very few people, if none, have terabytes of traffic. So what can we load balance? We can load balance almost 10 gig of traffic on layer 4 load balancing. We can load balance more than 8 gig of traffic when doing layer 7 inspection, more than 2 gig doing SSL offload. And it's not per NSX platform. It's per NSX load balancer. And you can have 1 load balancer, 10 load balancers, hundreds of load balancers. So it's per load balancer. So we can go actually pretty high and more than enough for the enterprise. Okay, let's go quick so I don't go turn late to the next section. What's new? So we improved in multiple areas the load balancing. The first one is we improved the number of applications we can load balance since 6.2. We could, from day one, load balance your LDAP, your LDAP-S, your DNS, your web. But some corner case applications don't listen on one TCP port or one UDP port. They listen on a port range. They are not very popular, but they do exist. And in the past, we could not load balance on a port range. We had to define a VIP, an IP address, and a port, not from port 5,000 to 6,000. Now we can. So even those corner case applications, we can load balance them. We increase the scale of each load balancer. You can go now we moved from 64 to 1024 VIP per load balancer. If you're part of those security freak I mentioned before, you have some some must to comply, or it's just nice to have for you, but whatever. If it's a must or nice to have, we support FIPS, so you can easily turn FIPS on. And we introduced DLB. What is DLB? It's distributed load balancing. It's a tech preview, I should say that. So it's available in the code, but it's not supported for production yet. So what is distributed load balancing? It's the same stuff, actually, than distributed routing, distributed firewalling, Romain explained before. So instead of running the service load balancing in a VM, it's running inside the ESX, in the kernel, as a process, and on actually all your ESXs. And so it doesn't change much in the logical view. If, let's say, you have a web tier that needs to talk to an app tier via a VIP, the traffic is still the same. It's the web talking to a VIP. Of course, the laser doesn't work on that screen. To the VIP, and the VIP will load balance to the app pool. Nothing changed. But actually, the real view would be that one. You have your web tier with the DFW, Romain talked about before, and the DLB running on the VNIC. And when Web 1 hosted on ESX1, let's say, wants to talk to the VIP and is load balanced to app 1, app 2, it's done by ESX1. When Web 2 talks to the same VIP, it's hitting its VNIC, and it's ESX2 doing the load balancing, and will be load balanced between app 1 and app 2. So now, where is my VIP? I don't know, it's everywhere. Okay? How much traffic can I load balance on that single specific VIP? I don't know, buy more ESX. Okay? So, let's do a quick demo. Can you switch? No? Yes? Yes. So how do you configure that? It's a tech preview, so the code is here, but we didn't make the UI for that, so it's as a trick. We don't have, you see, distributed load balancing somewhere here. So as a trick today, because it's a tech preview again, it's hidden under firewall, partner security services, which agree doesn't make sense, but yeah, we had to do it somewhere as a trick. And how do you configure that? So you say the servers you want as the servers that will hit the VIP, the clients. So you can put your VMs or use a security group, whatever, but that's the clients. And you configure your VIP. And your VIP, you can see it's a load balancing service, IPv4. My VIP is 1.7. I don't care about persistence, and I want to do basic stupid round robin. Okay? And when I load balance on that VIP, when I load balance on that VIP, where do I go to? Which pool? I go to that one, and that one has app 1, app 2. Okay, that's pretty much it. So it's pretty much doing your VIP configuration. And that, as I said, that won't be the most wahoo effect, but let me show you that in live. If I go to Web 1, so on SSH, I go to Web 1, and okay, I try to go to Web 1, and I'll ask, so I'll talk to my VIP on HTTP, and so that's my VIP 1.7, as you've seen before, and I ask a specific page. What is that page? It's the web server will reply the IP address of the client seen plus its own IP address. So my IP address was 1.11, and so the client is 1.11. The server did really see the source IP address of the client. There is no source NAT involved, and its IP address is 2.11. And then 2.12, and then 2.11, 2.12, and so on and so forth. If I go to my Web 2, and, man, fat fingers, I swear I didn't drink yet. Oh, come on. And I do the same. I go to 2.11, 2.12. I said it's not the most wahoo effect demo, but I'm load balanced. Where is my load balancer? It was done a little bit on ESX1 because Web 1 was there. It was a little bit on ESX2 because Web 2 was there. It's really distributed. So I can really, really scale out. Okay, you don't have to clap. Okay, so last section. So we can do a lot of things on load balancing, as I said. So why do we have an ecosystem? In firewalling, that was clear because that was enhancing our native layer 4 stateful firewall with antivirus, some deep inspection, blah, blah stuff. I mean, all the security things you love to talk about. But that was enhancing NSX. For load balancing, why do we have that? There are mainly two reasons, but a lot fall into the use case one. When you raised your hand at the beginning, like 40% of people are using NSX, which is pretty amazing. So you'll tell me at the end if you're part of this. But what we see, or what I do see, I don't see all customers, there are too many now, it's customers don't jump into NSX adoption like fully, like the whole body goes in it and trust completely VMware and jump into logical network and security with all the services. What I do see, they do baby jumps. They start with a good use case is micro-segmentation, use security only. They still don't use NSX for switching, routing, and load balancing. They just do the security. And then their guys, their operation guys, get used to the product and learn the product, how to manage the product. And then they go to the next step 6 months later, 1 year later, if they are not so, some customers are not very fast. And then they adopt L2 and L3 and things like that. But it's not that they embrace all NSX on day one. So, we have lots of customers like that, and even if we do load balancing, they keep their F5 they love, the Citrix NetScaler they love, even if they could do it on NSX. And that's fine with me. I don't mind. They love NSX for that little slice they use, and I'm happy with that. Another use case, but it's not so popular, because we do quite a lot, it's we don't load balance some blah, blah, XYZ application with corner cases that require some specific things on load balancers. So, as I said, we load balance plenty of applications, even more now with the port range. But there are some, like, I can name only one actually for now. I know we cannot, is diameter. If you're not a service provider, a telco provider, you've never heard about it. It's something for your cell phone, they use, but nobody else use. And for load balancers, it's quite complex. You need to look at the packets and do stuff. We don't support that. And then, yeah, it's a must. You must use one of those guys. So yeah, that's why we have this partner ecosystem, and that just Just one thing I wanted to tell you. It works whatever, if it's VM or appliances, we can integrate them. We test each release with those 4 vendors. If you have another vendor, it will work as well. There is nothing fancy in the integration, no requirement on their side. Just one word with F5, because we did a little bit more with F5, to be honest. And I have to recognize them and give them the credit. I can manage the F5 from NSX. So from the same NSX, click, 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 click you've seen, you can do click, click, click on NSX and boom, oh, it's on F5. For the others, you do click, click, click on NSX to do the L2, the L3, the DFW, the VPN. But if you want to do load balancing, you open another window, you have another screen, and you do click, click, click on their stuff, or CLI on their stuff, okay? So that ends up, I hope I'm not late, no? And let's go with the next and last section of advanced services.
Okay, for the final section, VPN services. So what are the usual requirements for an enterprise? You have applications, core business applications that generate revenue, that pilot something, industries, health. Or you have internal applications, HR systems, mail servers, file servers, CRM, and so on. And you have your headquarters, you have maybe servers on premises, you have maybe data centers, cloud providers, branch offices. And you want to connect everything securely. And you also have more and more employees that are nomads, working from home, like I do, or traveling, or assisting at VMworld. And for them, we provide a range of VPN services, layer 3 VPN with IPsec protocol, layer 2 VPN to extend your subnets to a remote site, and remote access VPN on SSL VPN. So the first one, it's a site-to-site VPN, so layer 3. You want to extend your subnets in layer 3, so you have different layer 3, different subnets on your site and on the distant site. And you can do that from NSX to NSX, if you have NSX in your data centers and headquarters and maybe in a branch office. You can create and establish a tunnel and you have communication. But maybe you have distant sites, remote sites that don't have NSX installed. What you can do is establish a tunnel to physical endpoints, your usual firewall vendors, on the standard IPsec protocol. So maybe Cisco firewalls, Checkpoint, Juniper firewalls, and you're done. And it's a cost-effective, it's a software-only solution. So you don't have to have an appliance, and you can scale out. You can, if you need more capabilities, more bandwidth, you just add more NSX edges. Something else that you have also is sometimes you have to extend your layer 2 subnets, especially when you don't want to re-IP your virtual machines. This can be a requirement when you have cloud onboarding or cloud bursting if you have a peak in your traffic. It can be used also for data center migration if you want to keep your IP addressing schema. It can be for brownfield NSX implementation. So what you do is that you have NSX in your primary site, and you don't have to have NSX in your secondary site, in your remote site. You only have to have to deploy an NSX standalone edge, and then you can establish a tunnel connection and then extend your layer 2 to the remote sites. So it's also a software-only solution, and it's cost-effective. Finally, the user access VPN. So you have your nomad users that are away traveling or working from home. And you don't always have the possibility to publish securely your application via HTTPS or via Citrix portal or via VDI. You have some systems that you need to access like file servers. And for them, you can use a remote user access VPN. And without that, the user will hit the firewall and won't be able to connect. But if you install the client or use the web-based mode, it will establish a tunnel connection and you will be able to connect to your headquarters or to your data centers. And we support client-based mode or web-based mode. And if you don't have the client, it's not a problem because you will connect to the portal. You will authenticate via one of our supported authentication method, Active Directory, LDAP, Radius, RSA Secure ID. And then you will be able to download the client, which is available on major OSs, Windows, Linux, and Mac. The use cases are the usual users that want to access their servers, but you also have the possibility to offer secure connection into your data center, into your servers for your administrator, for example. And I will finish here for my...
Okay, all good. So this ends up the detailed explanation on the 3 advanced services we have. Some key takeaways. So what you do have to remember. So as I said before, I mean, NSX reproduce all the network services, network and security services in logical space for your data centers. I should say I did say data centers because we support for a year now multiple sites as well. Keep this in mind. Why logical space is cool? As I said, because it improves your speed, agility, improves the security as well of your applications, and because of the distributed mode, it has awesome, humongous, like my son loves to say, massive, I don't know if you know that song. Okay, I have a little boy. A massive scale with the distribution. I said almost because load balancing is not there yet. It's tech preview, but it's getting there. And you can, NSX is not a product. NSX is a platform. Remember that one. So we have an ecosystem. We have an ecosystem in security. We have an ecosystem in load balancing. We have an ecosystem in other areas too, like management. We have great native tools, but we also acknowledge that you have your own tools. You may have most likely Splunk. You have some other tools to manage your stuff. And we have a rich ecosystem with those vendors to give you the same tools you love, and have those tools to manage NSX as well, or report, or monitor, or send alarms as well. So that's really the important piece to remember out of that session. Now, if you want to know more, to do more, 40% of you have already NSX, so that's fine. For the few who don't have that, we have plenty of hands-on lab. They are free. Use them. You can really play on NSX. That's pretty cool. You have deeper sessions, even deeper sessions for security, for load balancing. Something we didn't address much, or not at all actually, to be honest, in this session is automation. We talked about click, click, click stuff, which is cool. I mean, lots of customers still do click, 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 but everything we do can be automated. And there are some sessions like this one I'll do tomorrow on how to automate network and security services, so you don't have to do click, click, click anymore. And don't forget this one. That's a great way to talk to us. The community NSX, where you have also some documents that are not on the VMware website with the fully certified, which takes 6 months to publish, kind of documents. Still great fonts and great pictures, blah, blah, but a little bit slow. So those are maybe not as shiny on the fonts, but pretty cool documents. And you can post questions and things like that to talk to us. You can even reply to others and talk between customers. So pretty cool website. Okay, we have 5 more minutes, 6 more minutes, woohoo! So perfect. If you have questions, feel free, or we're all clear and that's all good. Yeah, oh, and we have goodies, by the way. Yeah. The question is, if you create a firewall rule, is there any tool that will validate this one doesn't conflict with another one? You want to take that one? Or take that one?
No.
So you can do a rule that will impact your other rule. You can, definitely. So if you say, you put all your rules, and on the first line you say any allow, or any block, then first rule matching will win. So that said, so you can shoot yourself in the foot, correct. That said, we have something called TraceFlow, which is an amazing tool. I don't know if you played with it. With TraceFlow, you can say, I want to go from that VM to that VM with TCP port 80 for HTTP, and you click, run the trace flow. This is actually sending for real the packet out of the VNIC of VM1. So you don't have to ask the root password of VM1, but it will inject the traffic just after the VNIC or before the VNIC. And it will go through the DFW, through the logical switch, the logical router, everything it has to go through, up to VM2. And at each stage, the element, the process, will report to NSX manager. So you will see the whole flow. And if something is blocked, because a rule is blocking, then it will say, oh, blocked because of that rule. If the physical fabric, because let's say it has to go from ESX1 to ESX2. VM1 is here, VM2 is here. And the logical network is you have some switching, some routing, some load balancing, some firewalling. At one point, it will go out from ESX1 to go to ESX2 through the physical world, the real world, big boxes. You will see that as well from TraceFlow. It won't tell you, to be honest, on which single switch you have a misconfiguration or something dead, but ESX1 will report to NSX manager, I send it to the fabric, and ESX2 will report to the manager, I never received it. Which means, where is the issue? On your fabric. And so you can test things like that. Okay? Long answer. Sorry for that. The question is, do you have any integration with AWS for security policies and things like that? So we are working on making an integration with public clouds. AWS will be actually the first one. We are looking also at, of course, everybody else. The second one will be Azure. But yeah, we are working on, so I don't know if you listened to Guido. It's our big boss, our CTO. So obviously it was a great session. I cannot say otherwise. But it was honestly a great session. And it talked about that. So now we're talking about roadmap. Everything I said before was today. So we are working on integrating this. And the idea, to support public clouds. And the idea is to configure your logical network, your logical security from this central place, NSX. Whatever if your workload is in your data center at home, in your own data center, or Amazon. Okay? We can talk, if you want, afterward about more technically how it will work. But yeah. Okay? We're definitely working on that. And look at Guido sessions.
This morning in the keynote, we were showing a tech preview of give suggestions of the most creative from there. When is that coming?
Shoot, I didn't. So now I have to, so stop the recording. I did not wake up to see to see it, so I don't know what you're talking about. But what I suggest, I know a guy who doesn't sleep much. He saw the session, so come and he will reply to you, because I didn't see that session, so I don't know what you're talking about. The recording was off, correct? Yeah. Okay. Yeah.
Is there any way to stop administrators who don't want to touch firewall rules from getting into that without taking much custom admin rules? Does NSX have its own?
So the question, I'll translate that in French to be sure I understand. The question is, do you have any role-based access control back to manage NSX? So natively, so you can create you can create roles, you can create users and roles. So you can have a role, Bob. Jean-François, I'm French. Jean-François has the role of a security administrator, and he can do everything. And Pierre is not a security administrator, and he cannot do it. Now, if you're a security administrator, we don't have the granularity to say, okay, the security administrator Jean-François can touch those kind of rules, and the security administrator Paul cannot touch those rules. If you're a security administrator, you can do everything. That said, if you do something, and customers do that, if you add a layer on the top of NSX an administration layer, like a cloud management system, let's use big words, like VRA, like OpenStack, or something above, so something above NSX, you can create those more granular roles to avoid conflicts between somebody touching my roles. All good? Hey, stop by, I have cool sunglasses and hat. Yeah, another question. Yeah, so the question is, do you want to take this one? No.
Yeah?
Yeah.
So your question is, are we offloading the SSL certificate into the load balancer? So yeah, in the general configuration of the edge and on the load balancing part, you can import your certificate with the certificate and the key. And then you have them available to apply on your VIP.
And then it's centrally managed, so that's cool. You don't have to deal with, but it's like any load balancer. It's the same way you would do it on the F5 you love or A10. Yeah. The issue is now I'm blind. So, okay. So I think he was first. The question is, if you're a VMware shop, you don't need checkpoint, firewall, and blah, blah, firewall. And yes and no. I will not tell you our firewall is the best firewall in the world, because I will have a hard time to say that. Our firewall is pretty awesome, and in terms of scale, in terms of granularity, because now you can even do firewalling in the same subnet. However, if you send an email, so let's say you have a mail server behind me, and I do the great load balancing and the high availability and all that greatness stuff. If you send an email with an attachment with a virus, I will let it go through me, because I don't look inside, okay? So now, what we can do with our ecosystem, you can still use NSX for everything L2, L3, load balancing, firewalling, layer 4, stateful firewalling. The word layer 4 is very important. But with our ecosystem, I can make a rule in my world, on NSX, to say if it's, help me, SMTP is what, 25? If it's SMTP and POP3 and IMAP, actually you don't have to use the ports, you can use the protocol name. So forget about 25. You can say if it's SMTP, POP3, IMAP, the action of my firewall is not allow. The action of my firewall is redirect to checkpoint, or redirect to Palo Alto Networks, or redirect to Fortinet. We have a number of partners in this ecosystem, and those guys will look inside the email, will look inside the attachment, and will do their beautiful job of checking this attachment is all clean. Okay? So you will, lots of customers use us plus Checkpoint, plus Palo Alto Networks, plus Fortinet still. So the question is, that last action is no more done in kernel. Yes, that said, it's still distributed. Why do I say that? Okay, first, if you'll, go to the session dedicated on that, but a quick answer. The way it is done is when you integrate with a third partner, Checkpoint, Palo Alto, Fortinet, some others, McAfee, Symantec, I don't want to forget the others. The way it works, on each automatically, there is no manual intervention, automatically NSX will deploy one of those vendors' VM on each ESX. So you have this VM on each ESX. Okay, ESX1 has it, ESX2 has it, ESX3 has it. And when, let's say you have a mail server on ESX1 and a mail server on ESX2. Okay? My action is when you see SMTP redirect to Palo Alto Networks, and it goes to server 1 on ESX1, then the action redirect will be on the VM Palo Alto on ESX1. If the destination was mail server 2 on ESX2, it will use the Palo Alto of ESX2. So now where is my Palo Alto firewall? It's a little bit everywhere. But fair point, it's not done in kernel. It's sent to the Palo Alto VM. And the configuration of those VMs, because now I don't know how many ESX do you have? 6. You don't manually go on each of those 6 VMs, because now you have 6 VMs, to configure it. You use the central management of that vendor. So if I say Palo Alto, I could have said somebody else. Palo Alto is Panorama. Panorama, you configure, yeah, if it's 25, you do this and that, IDP, blah, blah, and it's centrally configured and pushed to the 6th VM. If 6 months from now, you add a 7th ESX, don't touch anything. Automatically, NSX will add the VM, Palo Alto, and Panorama will configure it. No human intervention. Yeah? I know a little bit. To be honest, I don't know VCD too much. So I don't know if VCD is using today, currently, the benefits of distributed firewalling, or if it's still implementing it using central firewalling. So what I suggest, come back at the end, give me your business card, and I'll find you the right guy. Or do you know?
I don't know much about VCD.
Yeah.
I'm sure this is a stupid question. Can you
I'll give you an... Yeah.
to bring this benefit to a, let's just say someone has a physical server?
Yeah, I've heard physical servers still exist. I've heard that somewhere. For those who still have physical servers, what we can do is we can integrate physical servers to logical world. And there are multiple ways to do that. The first way is, it depends what you want in terms of network. Does your physical server is in a subnet, the same as your VMs? So let's say your VM is 10.10.10.11 and your physical server is 10.10.10.12. So you want L2 connectivity between the two. In that case, we do support that. We have a feature called L2 gateway. I guess in marketing we are not very innovative on that part. So we can do the bridging, and then it will benefit all the NSX capabilities. The only thing I want to say is, so yeah, if server 1 wants to talk to server 2 and you say on this subnet SSH is not allowed, I make it up, then it will be blocked. Because where? We don't know the physical server, but it will be blocked by this guy.
Right, because if you're in the same subnet with 2 physical machines.
Now, that's what I wanted to say. If you have physical server 10.10.10.12 and physical server 10.10.10.13, between 12 and 13, it's open bar. Because it's not touching my world.
Yeah.
You're not entering my world.
I don't know anybody who in their right mind would implement such a thing, but use a VLAN as a physical wire to connect that physical machine so it's on its own discrete VLAN, use your L2 bridging, then you can.
I can do all the stuff we talked about on security as long as you enter my world, my logical world.
Right, and it has to because
Yeah, so that's what, so physical, it's out of my world. So if they want to do SSH between them, yeah. No, 2 different VLANs, yeah, they want it to be blocked by, thanks to us.
have sequential IP.
Yeah. Yeah, because you enter the routing, and let's say the router is my world, so that's fine. Just wanted to, so that's today. We are working on something, so now roadmap. We're working on something with, you may have heard, hardware VTEP or top of the rack integration. So how do you do the VXLAN, VLAN communication? I'm not talking about security. We can do it in software or with hardware VTEP. I don't want to go in details, but it works in both ways. Today, no roadmap. What we're working on with them is when I create security policies, like you cannot do SSH, to translate that on the top of the rack so that's translated to ACL. Okay? So we are looking at that as well, but that's roadmap. Okay. So today, who is doing hardware VTEP? So the L2 communication done in hardware, not in software. Pretty much everybody but Cisco. Cisco is working with us now, actually, to be frank. And that's coming. I don't know when, but that's coming. Who will be the first one with the layer 3 ACL stuff I just talked about, the ACL stuff I talked about? I don't know who will be the first one, to be honest. Okay. All good? Yeah. Okay. I guess they'll shut me down. Shoot me down. Nobody wants a cool